All right, here we are. This is section 2.4, and we are introducing a very important part of what we are going to do for the next 2 months, probably. Okay, so we're going to be talking about how to solve certain types of equations that are involving polynomials in something that we call the factored form. So, before I proceed to do some of the exercises, solving some examples in the videos, I need to explain what factor form is and one property of mathematics. So, the equation you see here is what we call an equation given in the factor form. How's that? As you can see, there are two expressions. Both of them are inside parentheses. This expression is next to this other one. That means that they are being multiplied. They're multiplying each other. Then, this is what makes me understand that I have this equation in something we call the factor form, because we have two expressions, one multiplying the other. They're factors, okay? This is the first thing. Usually, we're going to be dealing with these equations set equal to 0, but there might be some other changes eventually in the future. But for now, we want to make sure that they are set equal to 0. The second thing I want to explain is what we call the zero product property. And I want you to take a look at this equation right here. We have the product of two terms, two variables, two terms. A multiplied by B is 0. When is that possible? Okay, let's take a look. This product 0 is going to be possible if either A is 0 or B is 0. It can be possible that both of them are the same time are 0, but that's just a unique case. As long as one of them is 0, it's going to be okay. Based on this, that either this or this is 0, and thus we confirm that we have a 0 as the result, now let's combine these two concepts to understand how to solve this type of equations presented in factor form. Well, you might see that this first factor right here, which is x minus 1, can be represented by the letter A. That is multiplied by now this other term that can be represented by the letter B.
Johnny Prescott, come to the main office, please.
So how does that help you? Well, help us see that if x minus 1 is 0, no matter what happens here, this times 0 is 0. On the other hand, if this expression x plus 3 is 0, then the whole thing is 0. With this, I am able to find the two possible values that x can have so that the equation is set equal to 0. How does that work? Well, I can now say that if x minus 1 is 0, then the whole thing will be 0, and now we are able to find what is the x value that satisfies this relationship. I just have to add 1 on both sides, so x is 1. And here I have one solution, but it's possible to have a second one because now I want to analyze the second term. I can also say that if x plus 3 is 0, then the whole thing will be 0, which means that I can now find out what is another x value that makes it possible. So the second possibility is that, or second solution is that x is negative 3. So if you take a look at this equation, I have two possible solutions. When x is 1, look at this, 1 minus 1 is 0 and makes this 0. Or when x is negative 3 right here, negative 3 plus z is 0 and making this whole thing 0. Okay, that's all.